Okay, good morning, everyone. I'm going to start. Everyone else will just join. I don't want to waste any more time. So, good morning, everyone. A very warm welcome to all our participants who's joining us online today. On behalf of the DVC Research and Innovation Office, it is my pleasure to open up today's webinar titled SDG Synergies, Water, Energy and Cities for a Sustainable Future. The session forms part of UWC's ongoing commitment to advancing the Sustainable Development Goals, particularly SDG 6, which is clean water and sanitation, SDG 7, affordable and clean energy, and SDG 11, sustainable cities and communities. Today's discussion will highlight how integrated transdisciplinary research is helping us navigate the intersections between water security, renewable energy transitions, and sustainable urban living, and ultimately shaping pathways towards a more and just future. We are excited to have a distinguished panel of UWC researchers who will be sharing their insights from their innovative work spanning from water purification to energy storage to ecological urbanization and climate governance. Before we dive in, I'd like to introduce our moderator, who is Prof. Bernard Bladdergroen, a systems innovator with over 25 years of experience in clean energy, water purification, and sustainable materials. He serves as a Deputy Director of the South African Institute for Advanced Materials in Chemistry and Program Director of UWC Sustainability Cluster. Prof. Bladdergroen's leadership in renewable energy and water technology has been internationally recognized and includes through the G20 Green Energy Forum. Prof will also guide us through this morning's program and later share his own presentation with us on Green New Technology World Technology Demonstration Platform at UWC, a water energy food ecosystem combining solar energy, cold chains, green hydrogen, green ammonia, and agriculture to drive sustainable development and local empowerment as well. So thank you so much again for joining us. And without any further ado, I will hand over now to Prof. Bladdergroen, who will open and moderate today's session for us. Thank you so much, Prof.
Yes, good morning, everybody. I hope you have a good one. As you heard, I'm your moderator this morning, and today's themes is the SDG, Sustainable Development Goals for Synergies, Water, Energy, and Cities for the Sustainable Future. So this topic is close to my heart. It really combines the various important topics like water, energy, and sustainable future. I think this is a very important seminar because in the end of the day, we're speaking about our future. So the global sustainable challenge is not just about addressing isolated problems. So it's about understanding how these different systems interact. And that is why it's so important to start studies that just don't look at single and silo kind of research. So I think there's a lot of things that we can achieve if we start understanding how different people think and what they can contribute to the situation. So the panel that we have today is exactly representing that kind of thought. The people coming from different backgrounds, they have different ideas, different opinions, and those things will make things much stronger in the end of the day. So access to clean water, for instance, it depends on energy. So if you have energy, you have clean water, or you can at least purify your water and irrigate and do all kinds of things. So energy plays a very important role. But in order to create energy, you often need water as well. So it works on both sides. And then I think the inclusion of food specifically, and that's something that we have been looking. Personally, I've been looking into that, and I think that really kind of completes the effort So over the next hour, we'll hear from several speakers. I will introduce each of them one by one, and they share their insights and their knowledge on that specific area of expertise. And only after all the speakers are finished, we will open the floor for discussions and Q&A. So please, if you have questions, don't wait with them, or at least write them down somewhere, preferably in the chat, and we will address all these questions at the end. So the first speaker, I'm just going briefly, quickly through the speakers. I don't do a formal introduction yet. That will be done just before they're starting. But our first speaker is Professor Leslie Patrick, and she will speak about potable water for unconventional sources of climate resilience. And Professor Patrick pioneering work explores how we can secure water resources using innovative treatment technology. So water is going to be a very important topic in the future, even if it's already not already there. It will become increasingly more difficult to get water and of the right quality. So this is one of the topics that we would like to hear about. And then the second speaker is Mr. Rida Manuel, and he will talk about the solar-powered hydroponic system. And this system demonstrates how renewable energy can directly support sustainable food production in urban and peri-urban contexts. So next, after that, we have Miss Ashleen Davids, and she presents on the topic of the towards ecological urbanism, integrated natural-based solutions and urban green infrastructure in South African law or local government law and policy instruments. So highlighting the importance of policies, because without policies, most likely these integrated systems, they're not going to function and they're not going to be implemented. So that is finally I will show what we do in terms of the Green New World. People may have seen some activities next to the Petrosay site where we're building this demonstration platform. So I will be happy to speak to you about that. I think across all the presentations, there's one theme that stands out. It is integration. So it's how we all integrate, how, again, all these different philosophies, all the different ideas, they get together to make a system more robust. So we talk about clean water, renewable energy, sustainable cities. The message is clear: achieving the SDGs requires collaboration across disciplines, sectors, and communities. So again, that is very much what this seminar is about. Yeah, I would like to thank the Office of the DVC Research and Innovation for organizing the important event, and our speakers for their thought-provoking contributions, and for all of you for joining. So sustainability isn't achieved in isolation. It's through synergy between disciplines, between people, between ideas. So that's how we manage to realize real change. So I think we can go to the presentation. I would like Leslie Patrick to start sharing her first slide so that we can see if that's all working, and then I will read the introduction. And also remind Leslie that the presentation is supposed to be 15 minutes. I will switch on the video 2 minutes before the time is up, so that you have an indication to wrap up, so that we have all time to complete. So I will read now Professor Leslie Patrick's the introduction. So she is a renowned chemist with expertise in material science, environmental chemistry, and water treatment. She earned her PhD in chemistry from the University of Western Cape in 2008 and established the Environmental and Nanoscience Research Group, leading numerous local and international projects. So Professor Patrick has authored 236 journal articles, 11 book chapters, and over 300 conference presentations, with 5 patents to her name. Her Google Scholar metrics include an H index of 56 and an I-10 index of 182. And over 10,000 citations are obviously showing she is very much, she has been very, very, very busy in this field. She was awarded the NSTF South 32 Award in 2018 for her contributions to science, engineering, and innovation. And she received the Water Legends Award from the Water Research Commission in 2021. So, Leslie, we're looking very much forward to what you're presenting today on your topic of the water, or where the future of water is going and where the water is coming from. Over to you.
Melanie, would you put my presentation up, please?
We'll do so shortly, Prof.
Are you able to put up my presentation?
Yes, Prof. It's just loading. It's just loading, Prof.
Okay.
Is it showing, Prof?
I'm still seeing a blank screen. Oh, there we are. If you can put it on presentation mode.
Is it up, Prof?
Good
It's
day.
in presentation.
Yes, there
Okay.
we are. Thank you very much.
Okay.
Good day, everyone. Thanks very much for this opportunity to speak to you today. I'm going to be speaking to you about potable water from unconventional sources for climate resilience here in our own city, Cape Town. Next slide, please. Obviously, we want to address the SDG goals, and I'm going to be speaking to you about our project that we did with Norway on the San Ocean funding, where we were looking at the particular issue of unconventional sources of water and the impacts of it in our environment. Next slide, please. So this slide here shows you the problem of bacterial contamination across the world and the number of deaths per million on each continent. And you can see that the situation in Africa is still pretty dire. And in our own country, we have a similar problem. Next slide, please. So bacterial contamination is not the only problem that we have. We also have chemical contamination, and this has not been very well recorded globally. And you'll see there are only some figures coming out of South Africa and one or two countries to the north of us. But it's a big problem in the industrialized countries, and you can see that, for instance, the USA is very contaminated with these chemicals. Next slide, please. Now, Cape Town has been thinking about this problem ever since the drought hit us, and they've actually created a policy document called Our Shared Water Future, in which they're trying to understand how we can make ourselves climate resilient, given the very big drought that we had not so long ago. Here, I've just got a bit of a deep river sampling report. This is the river leading into the Potsdam wastewater treatment plant. And you can see what the fecal coliform contaminants are at those various points impacting our riverine sources here in our own city. Next slide, please. Now, when we had the drought, the city was actually monitoring how much water people were using. And here you can see the median kilos of water being used by different parts of the city. And you can see that some of us were not very careful with our water usage, whereas many other people were using a very low water usage. That was in 2017 when the drought really hit. Next slide, please. Now, when we have a drought like that, here you can see how the city's policy to try and get us to use less water worked. And you can see how the kiloliters being used dropped during those very strict drought months. So there is a possibility to use demand side control to make water go further. And the city at the same time implemented a very strong effort to stop leaks. Next slide, please. But the quandary really is that the city has been thinking about the strategy to produce drinking water via unconventional sources, which are seawater desalination, groundwater, or effluent reuse. And for instance, in the desalination tender documents that were put out for the first desalination plants, the city made the assumption that the tens of millions of liters a day of untreated or partially treated sewage effluent that is being discharged into the ocean via the marine outfalls or wastewater treatment plants, surf zone discharges, that this is adequately dispersed out into the sea. And they were assuming that the intake seawater to the desalination plants would only contain inorganic salts and not organic chemical pollutants or microorganisms. And their brief was to produce water that would comply to SANS 241. But, next slide, please. This was their plan. I've covered this already. Next slide, please. It's already been shown that in our drinking water, there are numerous pharmaceuticals, for instance. This is a study done by Patterson quite a long time ago, who found all these different types of pharmaceuticals in our drinking water across the country. And I might add that we've been recently part of a study looking at perfluorinated compounds in our drinking water in South Africa, and the picture's not pretty. Next slide, please. Now, when we look at our drinking water, we need to look at other countries as well. And here you can see that these compounds are turning up in many different parts of the world. For instance, acetaminophen is turning up in the USA, Spain, and the levels are quite worrying. You can look at estradiol, for instance. There are levels that they are finding in these drinking water supplies. Thank you. Next slide, please. Now, emerging contaminants are contaminants that are organic synthetic compounds that we have made generally, and they include things like pharmaceuticals and endocrine disrupting compounds, personal care products, nanomaterials, perfluorinated compounds, and pesticides. And you can see under each one of those major classes that there are many other compounds that are falling under those systems. And you're very welcome to go and read some of our literature on this. But these are compounds that are highly resistant to degradation and persistent in the environment. They don't break down very easily. Next slide, please. Now, the reason why we worry about emerging contaminants is all these particular problems. They cause feminization and downward trends in semen quality. They cause declining sex ratios and sexual abnormalities, developmental abnormalities, reproductive impairments, endocrine disruption, and antibiotic resistance, structural deformities, gene alteration, and various cancers. And obviously, the risk depends upon the concentration, exposure time, volume, complexity, the organism type, the metabolism rate, etc. So it's very difficult to predict exactly what the effects will be, but they are there. Next slide, please. So SANS stipulates these following compounds, but they don't specify any of the emerging contaminants as yet. There are plans to try and augment this, but this is what the city is mandated to supply to consumers. So they're not checking for the endocrine disrupting compounds. Next slide, please. In the study that we did for direct potable reuse, that was a Water Research Commission project, we had a look at whether one could reuse sewage. Next slide, please. And basically in that study, we thought about what compounds we should test for. And we tested for compounds detected in South African potable waters, compounds which were persistent, compounds that were not removed by water treatment processes. And we also looked at what pharmaceuticals were prescribed in the largest volumes in our cities, and which are high-risk priority pesticides. And we also chose chemicals representing each group of the emerging contaminants as indicator compounds. Next slide, please. And these are a list of some of the compounds we decided to assess. Next slide, please. And this is more or less what the reference dose is for drinking water quality for international standards. And you can see these levels are pretty low. Next slide, please. This is a typical wastewater treatment plant treatment train. And you can see the wastewater gets screened when it comes in, then sand and grit is removal, and the solid sludge is settled down. And we tested 4 different wastewater treatment plants. That was the Beaufort West wastewater treatment plant and potable reuse plant, the Zandvliet wastewater treatment plant, the Belleville, and the Scottsdene. And we sampled them 3 times. And here's what we saw with the perfluorinated compounds. Now, I want you particularly to look at A, which was the Beaufort West water treatment plant. There, they're recovering the water for drinking water. And you can see that A was generally quite clean in terms of the effluent, the orange marker, except that some of the perfluorinated compounds were coming through, whereas you can see the other wastewater treatment plants were not very good at removing these compounds from water at all. Next slide, please. And for instance, alpha estradiol was coming through in wastewater treatment plant A, which is the one that had the reverse osmosis system on it. So you can see there that the estradiol was actually coming through the reverse osmosis membrane. And this is the female hormone. So everybody in Beaufort West is busy drinking female hormone in the recovered water. And you can see the other plants were also not very good at taking the female hormone out. Next slide, please. So the summary from that study is removal from wastewater is not destruction, because it goes into the solid residues that often get used for fertilizer. We couldn't test for secondary byproducts, and these compounds are supposed to only be escaping at about very low levels, yet we're finding a lot of them as the primary compound in the effluents. And the removal is highly variable and different for different compounds and different treatment systems. And the wastewater treatment, even in the best operational system, is not adequate to clean the water properly, even in the potable reuse system at Beaufort West. And that phase transfer from the water to the solid phase means that those solids are highly toxic. And of course, reverse osmosis is not 100% effective, and one needs to remember the brine needs disposal, and that brine is very toxic. And in that system at Beaufort West, they were using advanced oxidation, for instance, UV light, and it wasn't adequate to take these compounds out. And our study actually concluded that potable water from wastewater reuse is highly problematic. Next slide, please. Now, the city also had plans for desalination. And the first desalination plant was supposed to be there close to the marine outfall in Sea Point, but they've now moved it to Pardon Island, which I would say is actually even less suitable than this particular point. Next slide, please, because Pardon Island is actually right where you have the outflow from the Athlone wastewater treatment, from the Potsdam wastewater treatment, from the Caltex refinery, and from the harbour, as well as from the Greenpoint effluent. And you can see that all this water goes into the ocean, if you look at the red section. And if desalination needs to be done, it needs to be done properly, because it goes straight to the consumer without any place where the water can be kept aside and tested properly for safety. So it is actually going to be put straight back into our reticulation system. Next slide, please. Now, these are the wastewater treatment plants around Cape Town, and you can see the marine outfalls at Greenpoint, Camps Bay, and Hout Bay, and then the big wastewater treatment plants, for instance, the Cape Flats wastewater treatment plants. And these are the liters of the megaliters per day that they're releasing every day into our marine environment. And if you've had any look at the Green Drop report, I didn't show it here, but the City of Cape Town's wastewater treatment plants are not doing very well. The effluents are very contaminated. The city is trying to improve the matter, but really and truly our effluents are not at all clean. Next slide, please. And here, for instance, is the raw sewage that's being pumped out at the Greenpoint marine outfall, which is just about a kilometre away from the coast. And that plume of effluent, so what you're seeing, the white stuff there, is actually the toilet paper and the poop. And those little dots on it are the seagulls that are having a feast. Think about that. And that is going back to our shoreline, as we will show in the next slides. So here, these are the chemicals that we found in the marine biota around the Greenpoint area. And I want you to look at the y-axis in terms of nanograms per gram in marine biota. These were mussels, limpets, urchins, starfish, sea snails, and seaweeds that we tested. And you can see that each one of these creatures had a plethora of these compounds in it. Next slide, please. We found the same picture in Camps Bay. Next slide, please. And we also found the same picture in False Bay. Here are the mussels, for instance, where we found these compounds in the mussels. Next slide, please. We also found these compounds in the fillets of fish. You can see the perfluorinated compounds were very present in the fillets of the fish, and compounds like diclofenac, which is the stuff that you rub on sore muscles, as well as herbicides. Next slide, please. And the hazard quotient for these fish samples were very high, especially for the perfluorinated compounds. Next slide, please. And when you look at our levels compared to other cities, you'll see that the levels of the perfluorinated compounds are much higher than elsewhere. And this is just a variety of the perfluorinated compounds. There are about 20,000 different perfluorinated compounds and hundreds of thousands of synthetic compounds that we are not even able to test for. Next slide, please. Now, the other thing about these desalination plants is that they have the issue of the algal blooms. Now, this is the algal bloom that was in False Bay at the time that we were testing for those particular compounds in False Bay. And the red is showing you the very high algal bloom level, depending on the season that it's taken. Next slide, please. And that had a direct effect on the three desalination plants. These are the V&A Waterfront, the Monwambisi, and the Strandfontein. And you can see in October and November and December of 2018, all of those plants blocked because of the algal blooms. Now, algal blooms don't appear for nothing. They grow because of the amount of ammonia from our urine and phosphates, etc., that are going out into the ocean. And when that, next slide, please, when that all combines with temperature, you see a huge bloom, and we've even started seeing blooms right now, and it's not even very hot yet. So the algal blooms are dependent on sea temperature, nutrient load, wind direction, and external sources of nitrogen and phosphorus from agricultural runoff, household runoff, sewage effluents, and storm water. Next slide, please. So finally, we have Hobbes' choice, because we basically have to consider that desalination versus reuse as sources of water during a drought. And if you look at the desalinated water, it's very, very expensive. This was a price we worked out in 2018, whereas the ordinary water that we get from taps is about R5. And when we have a look at desalination, it's a very costly alternative, and therefore they see wastewater reuse as a less costly alternative. And the city is currently upgrading the Zandvliet wastewater treatment plant to become a reuse plant, and they're going to be injecting that reused water into our system. And at this point, they are not mandated to do anything except meet the SANS 2-for-1 guidelines. Next slide, please. Now, is there hope? And I just want to point out that we've been working for quite a long time, and we have got numerous publications on how one can take these compounds out of water in the treatment train at the wastewater treatment plant. So there are a variety of techniques that we can use. UV is a possibility, but it's far less effective than some of the other technologies that we're working with. And please watch this space. Thank you very much. There's one more slide, I think. So our recommendations really is to practice great caution with unconventional water sources for potable reuse. We have to treat the retentate from reverse osmosis as highly hazardous, and we have to treat sludges from sewage plants as highly hazardous. We really need to prevent the release of untreated or partially treated sewage to the ocean or surface water. We really need to include limits for endocrine disrupting compounds in drinking water guidelines and make our wastewater treatment discharge standards much stricter. We really also need to initiate a chemical awareness campaign to consumers, and I'm hoping that some of you have taken note of what I've said today. And we want to be encouraging the city to really look at combined advanced oxidation systems that are much stronger than UV, and implement proper barriers and monitoring programs and assessment programs to eliminate or minimize the risks. And we need to test that water for toxicity, the drinking water, which need not be costly, because one can use your tox kits for that. You don't need to go to all that analysis that we did. And we are the ones that created this problem, so we need to think our way out of this. Thank you very much.
Thank you so much.
Last slide.
Okay. Yeah, acknowledgements. Thank you very much, Leslie. It was very, very interesting, even for somebody that is quite busy in this space. There's a lot of new information, and I'm sure that many people are kind of shocked to see the reality of where we are at the moment. I see there's one question, but we will take questions at the end of the seminar. And I guess Leslie can look so long and prepare an answer for that. We are right on time for the next speaker. So I would like to introduce Rida Manuel. Rida Manuel is the coordinator of the Energy Storage Graduate Program at the University of Western Cape, where he trains engineering graduates and manages projects in renewable energy and energy storage. He is also a project manager for the agrivoltaic project that will combine energy, food, and water purification in one system. This project is funded by the EU and will be the first of its kind in Africa. Rida has a degree in mechanical engineering and is busy completing a master's degree in energy. The master's thesis focuses on the development of a mobile renewable energy system. It combines solar and wind energy, and he hopes to complete his PhD in agrivoltaics, and through it develop a system that produces off-grid and sustainable food, energy, and water. Rida is also the founder of a company called Green New World, whose vision is to build a sustainable system through knowledge, innovation, and empowerment, a system that provides food, energy, and water for people of Africa. Green New World, in partnership with UWC, will soon begin the rollout of 50 solar-powered hydroponic systems for the less fortunate in South Africa, and that is the topic of this discussion today. So Rida, you can start sharing your screen, and we're looking forward to your presentation.
Thanks so much, Professor. Is the screen showing?
And people, please be reminded, just keep posting questions. Don't forget about the questions, because we would like to answer all of them. Go ahead, Rida. Thank you. Yeah.
Okay, is the screen showing?
Yes, you can go ahead. Thank you.
Okay, thanks so much, Professor. As Professor said, my name is Rito Emmanuel, and the founder of Green New World. With my laser pointer. And I'll be speaking about the solar-powered hydroponic system. This project is done in sort of collaboration with Islamic Relief, which is an NGO, which is interested in the impact on the people, the impact on humanity, feeding people, and also funded by Synergies, who is obviously interested in the development of the technology. So in this way, this project is not only about the development of the specific technology, but also this project will have a direct impact on people's lives through this NGO. We will roll out about 50 systems throughout South Africa, in the Western Cape and KwaZulu-Natal. And the systems is intended to provide food for the people of the household, but also provide a means of income by them selling the crops that the system will produce. So it's not only about producing technology for the sake of producing technology, but also producing technology that can directly impact people's lives. So I'll be speaking about this. It's all started off with the assessments of homes. So we went out with Islamic Relief to these areas, and this was Mitchell's Plain, Khayelitsha, and some houses in Athlone. And some of these conditions is also similar to many of the homes in Cape Town. So the first thing we found is that around the house, which is the case, as I said, with many homes, is limited space for farming and for growing crops. It's basically mostly narrow alleys along the sides of the homes. And so the solution to that problem, we would say, is to build a vertical system, and that can be mounted on the wall, that will still allow space for people to move around their homes. And then the second thing we found was most homes didn't have electricity. They had maybe access to the grid, but they couldn't even afford the electricity. And in other cases, we found long leads running outside to run certain systems. And this can obviously cause a shock risk. And then, so then the solution is that is not for the people to have to plug it into their homes, but to build solar-powered systems that will actually power the system. And then there's also the risk of the people of the homes not watering the system and not adding the fertilizers in the required intervals. And so we are going to show you how we developed a self-irrigating system. So you can program the system to irrigate itself and therefore to nourish itself through the nutrients. And then some of the days we went to the assessments, we found very cloudy days. And obviously, if our system will be solar powered, that's going to be a big problem. And so we then had to develop a battery pack to basically provide backup power for when there is no sun during night times or cloudy days. You can still use the energy of the sun when there is no sun to power the system. And then there was the aspect of the safety of the system. And so things like insuring the system. And then we're adding a motion detection light in the yard. So if anybody enters the yard, that light will go on. And that's obviously off-grid. It's solar powered by the solar panel itself. The people of the household will be alerted of. And we're also adding a dummy camera as well, saying that you're being watched. And then from the first system we installed at my home, which I'll be showing you, I found that the system is quite secured into the Viber crate. So it's very difficult to actually remove. And then there's also limited access to water. And obviously there's no water points, as you can see at any of these points that we will be installing it. And so the solution is to build a system that basically uses the same water and recycles through the system all the time, which we will show you in the next slide. And so based on all the assessments, we designed and we built a prototype. And so just to give a brief understanding of how it works, so all the water and the nutrients is placed into this container over here. And that pump inside there pumps that water through up to the first pipe, then moves to the second pipe, to the third, to the fourth, and then it goes back into the same container. So that same water is being recycled through the system all the time, opposed to conventional farming where you have to continuously water the soil, and therefore this uses 90% less water than conventional farming, and obviously prevents the people that is at those homes who already doesn't have access to electricity and because of cost of the electricity and the water, they now can use the same water, save on water, save on electricity with this specific system. So that pump that is pumping and powering the system basically is powered by the sun. So usually a system like this, there's a lead running from the pump, and it needs to be plugged in. That's what we saw at some homes. It needs to be plugged in, and that is what presents the shock risk and damage to the house's electricity. So that pump is powered by solar energy, and it can be powered even if there is no sun and even if it's nighttime due to the battery that provides the battery backup, and it can provide up to 3 to 13 days of autonomy depending on the intervals at which you water the system. And that is because the battery is big enough to provide that amount of energy for that amount of days. And the system itself, as we said, powered by a 200-watt solar panel. And this solar panel charges this battery within, according to our calculations, within 2.5 hours. And the reason we needed the battery to charge as quick as possible, because the window that these yards have is very a short period of time through which the solar, the sun passes over that specific part of the yard. So I installed one in my yard, and it only gets about that amount of hours or a bit more hours of sunlight. So we needed the solar panel to charge the battery as soon as possible. And so the bigger the solar panel, the quicker it charges and fills up the battery. And then it passes from the solar panel, it passes through this box. So this box is this box here. It passes through a charge controller, which basically kind of protects the battery and allows it to be charged correctly. The battery itself is lithium ion because that is the technology available. But there is concerns about lithium being more or sodium rather being less more environmentally friendly than lithium. And so we are planning to shift from lithium ion to sodium ion. And so that specific battery can also be built by our students. I don't know if you know, we also have a lithium ion production facility across the road from UWC, and also the ability to actually manufacture battery packs. So we can buy in the sodium ion battery cells and then manufacture these battery packs, and that will even reduce the cost of the system even more, and provide even more learning to our students and to our program. And then there's also a timer within this system which allows you to program the system to water itself basically. So if you require for twice a day, it needs to run for 2 hours, you can program the system to do exactly that. You can program to run at 10 o'clock until 12 o'clock, and then program it to run from 2 o'clock to 4 o'clock in the afternoon. And that cuts out the risk of you obviously forgetting to water the system or forgetting to add the nutrients. The system does it for you. So that's the part of the automation. And then also for some systems, we're upgrading the system with a specific inverter and the ability to basically monitor the system remotely. So I can sit here or sit at UWC and monitor the system at my home from my laptop. Basically understanding if the solar panel is charging the battery in time, and understanding the fluctuations of how it's getting charged and how it's discharging into the battery. So studies will also be done into the solar panel battery relationship with the system. So that's the system. Then this is basically the first installation that we did at my home. So obviously the system is a combination of energy and food, and the production of food means that someone obviously needs to eat it. So it can't really stand at the university for too long. It needs to be installed at their home because the food is being produced. And we also want to study how it is to basically live off the system. As we need it in the kitchen, we come out, we cut from the spinach, or we cut from the lettuce, we add it to our salad. And we also want to test growing very big crops in here, such as cabbage, which is one of the requests from the people from the townships. They want to grow big crops in order to provide, to make pots of food and also sell to the community. And so we're going to do that test in the system. And then we are going to compare the growth within the solar powered hydroponic system with firstly conventional growth. So this is just a grow bed with soil in, and that exact same crops is basically placed into the soil. And we're basically going to compare the growth of these crops in soil compared to the growth of the crops within a hydroponic system, basically. And then we're also going to compare it to the most basic form of hydroponics called the Kratky method, Kratky hydroponics. So this is basically a container. We place the water into this container and we place the nutrients into this container. And on that, we have a floating raft, which then allows the roots to hang and grow freely within the water. So we're going to compare the growth of this compared to the growth of that same crops within the hydroponic system. So obviously within the Kratky method, the water is stagnant, it's standing still. Within this method, the water and nutrient is constantly moving and constantly being renewed for the plants. And then we're also going to test it compared to, so this is also Kratky. So we have water and nutrients, exactly the same as that. And with the floating raft inside with all the plants, that roots then hang into the water as well. But here we're just adding the greenhouse to provide optimum conditions for growth for the plants. And then we'll obviously be able to draw our different conclusions. This is obviously much lower cost than this system. And then is it worth it to basically spend all that money on growing it using this method maybe? And according to our calculations and previous experience, crops in this system grow 5 times faster compared to normal growth. But we didn't really compare it to systems like these, very low cost hydroponic methods. And we'll obviously then, after a month, be able to have some good conclusions on what is the best way forward. And the ultimate aim on the Islamic Relief NGO side is to provide those people with adequate amount of food for their household and to sell the crops to generate an income. And then we ultimately also want to build a training center where people can come and we set up these same systems and we train people how to basically use these systems. So in conclusion, we believe that these systems are very important systems for sustainable cities of the future in providing food security for those cities, bringing the food production to the cities instead of having to produce food, cutting down forests to produce food in faraway lands. And by the time it reaches the city, the nutrients is gone. So this will provide food for the people of the city and hopefully provide food for the people of the townships and the villages of South Africa and Africa. Thank you.
Thank you. Thank you very much, Rida. It's very nice to see very practical approach of innovation. It's nice to see that you're testing different methods and trying to find out what is the best way forward. So thank you very much for your contribution. And I think we are right on time to move to the next speaker, Ms. Ashlyn Davids. So she, yeah, you can just stop sharing so that the next slide can go on. But Ashlyn Davids, she is doing a PhD in environmental law at the Global Environmental Law Center at the University of Western Cape. Ashlyn holds a Bachelor of Commerce in Law degree and a Bachelor of Laws in and a Bachelor of Law degree and a Master of Law degree in Environmental Law from UWC. So her academic research focuses on the biodiversity crisis in South African cities, specifically the city of Cape Town. Ashlyn's research looks at how nature-based solutions and urban green infrastructure can be integrated into the local environmental and biodiversity legal and policy framework to strengthen urban resilience and mitigate climate risk and enhance biodiversity conservation. Thank you so much for joining us, Ashlyn. Can you are allowed to share your slides and impress everybody that's listening.
Okay, it's sharing now.
Put it, yeah.
Good morning, everyone. My name is Ashlyn Davids.
Thank you.
Okay, can you see? Sorry, it's a bit slow on my end. Can I start?
Perfect. Thank you.
Okay. Good morning, everyone. My name is Ashlyn Davids, and I'm a PhD student at the Global Environmental Law Center. I would like to say thank you for giving me this opportunity to present my research proposal. The title of my research is Towards Ecological Urbanism, Integrating Nature-Based Solutions and Urban Green Infrastructure in South African Local Government Law and Policy Instruments. The problem statement. The city of Cape Town is known for its rich biodiversity. However, the expansion of cities places pressure on this biodiversity and the ecosystem services that flow from it. Urbanization and rapid sprawling have led to a biodiversity crisis in metropolitan areas. Nature-based solutions and urban green infrastructure are recognized as critical tools to strengthen urban resilience. Nature-based solutions refers to actions that protect, restore, and sustainably manage ecosystems to address societal challenges while providing biodiversity benefits. Urban green infrastructure is a network of natural and semi-natural areas that enhance biodiversity and provide ecosystem services. However, the extent to which municipal legal and governance frameworks in South Africa enable or constrain the effective integration of NBS and UGI into local biodiversity and spatial planning remains unexplored. This study seeks to fill this legal and governance gap. The Constitution of the Republic of South Africa, 1996, guarantees the right to an environment that is not harmful to health or well-being and that is protected for present and future generations. Legislation such as the National Environmental Management Act, the National Environmental Management Biodiversity Act, and the Spatial Planning and Land Use Management Act, amongst others, aim to give effect to this constitutional promise. Importantly, these legal instruments also provide local governments with broad mandates to develop and implement local environmental governance instruments, including integrated development plans, spatial development frameworks, environmental management frameworks, and municipal bylaws. Municipalities have a mandate in terms of the Constitution, environmental, biodiversity, and spatial planning legislation to protect the environment and conserve biodiversity. As such, they have a broad authority to integrate biodiversity into several local governmental instruments and plans. They may also create bylaws and develop policies with a conservation agenda. In practice, however, municipalities in South Africa struggle to translate this mandate into effective action. Despite having formal tools at their disposal, municipalities often face institutional fragmentation. As a result, environmental considerations tend to be inadequately embedded in spatial planning and budgeting processes. The concept of ecological urbanism provides a useful framework to interrogate this regulatory gap. Ecological urbanism challenges conventional urban planning by placing nature at the center of city making. However, for this vision to materialize, legal and policy frameworks must evolve to make NBS and UGI enforceable at the municipal level. This research will critically evaluate the extent to which local government law and policy instruments at the hand of a case study of Cape Town enable or constrain the integration of nature-based solutions and urban green infrastructure into urban biodiversity governance. Rationale or significance of the study. The study introduces ecological urbanism, a relatively underexplored framework in South African legal scholarship, as a basis for rethinking the interface between law, planning, and urban nature. By linking ecological urbanism to NBS and UGI, the study builds a conceptual bridge between theory and practice, offering a legal lens through which these concepts can be embedded in enforceable local governance tools. While South Africa has progressive environmental laws, the implementation often falters at the local level due to vague mandates and limited capacity. The research offers a focused legal examination of how those frameworks could be improved to support effective municipal biodiversity planning. It also addresses the normative gap in current legal literature, which has not yet fully engaged with the practical governance potential of NBS and UGI. By developing a legal and governance framework for integrating NBS and UGI within municipal instruments, the study contributes to both academic scholarship and to the urgent practical task of making South African cities more sustainable. The research question. The goal of this study is to explore what are the options in law for municipalities to integrate nature-based solutions and urban green infrastructure in their local environmental governance instruments. The aim of the study. The study aims to critically explore how South African municipalities, specifically the city of Cape Town, can give effect to their broad environmental governance mandate by integrating NBS and UGI into their law and policy instruments. The hypothesis and assumptions. The hypothesis. The integration of NBS and UGI in local law and policy instruments is a significant but underutilized approach to addressing the biodiversity crisis in South African cities. Assumptions. Currently, biodiversity in South African cities is endangered because of the impacts associated with urbanization. Local government in South Africa have a constitutional obligation to protect and conserve biodiversity. NBS in cities are currently more orientated to climate change adaptation and regulating ecosystem services, which may substantially influence urban policies. UGI is a key component of NBS for enhancing biodiversity and urban resilience. The scope of the research. This research is limited to one metropolitan city in South Africa, namely the city of Cape Town. Cape Town is an appropriate single case study for this research because of its unique status as a global biodiversity hotspot. Cape Town offers unique accessibility to diverse stakeholders, ecological richness, governance structures, and policy frameworks. The city's biodiversity is under significant threat from urban expansion and climate change, making it a crucial area to study the impacts of urbanization on ecosystems. There is a need to carry out the study because biodiversity loss has significant impacts on human quality of life, while UGI and NBS can offer solutions for mitigating these impacts. The research methodology. The main methodology comprises doctrinal legal research analyzing primary legal sources, including the Constitution, NEMA, NEMBA, SPLUMA, and municipal bylaws. This review will also include secondary legal sources such as journal articles and research reports. This research will employ a case study analysis consisting of one municipality, namely the City of Cape Town Metropolitan Municipality. This doctrinal legal research method will also be supported by a social legal based method. This part of the study incorporates empirical research comprising of data collected through semi-structured interviews. The interviews will be conducted with selected municipal officials from the COCT. Ethical considerations. The study will adhere to university ethical protocols, particularly in relation to interviews and municipal data access. Informed consent will be obtained for all human subjects. Confidentiality and responsible data use will be ensured throughout. The literature review. NBS is a new concept that has been receiving increasing attention. Nonetheless, there is a lack of scholarship regarding their specific application in South Africa, particularly in the urban context. Raymond et al. Defines NBS as solutions to societal challenges that are supported by nature, which are cost-effective, simultaneously provide environmental, social, and economic benefits. Similarly, the IUCN defines NBS as actions to protect, sustainably manage, and restore natural or modified ecosystems that address societal challenges effectively, simultaneously providing human well-being and biodiversity benefits. South Africa, however, does not accept the IUCN's definition of NBS because there is no multilaterally agreed definition. As a result, a lack of operational clarity presents obstacles to the credibility and applicability of this concept in the fields of conservation and development. This research will address this gap by identifying the challenges and opportunities for NBS implementation to strengthen local governance policy innovations. UGI is a new term, but it is not a new idea. Detroit et al. Defines UGI as all natural, semi-natural, and artificial networks of multifunctional ecological systems within, around, and between urban areas at all spatial scales. Wang et al. Highlight that UGI is pivotal in urban planning and biodiversity conservation. However, Kita and Kuroma highlight that most government officials and academics agree that current policies regarding UGI have not been implemented. Many municipalities also lack clear mandates to consider UGI. The study will address this gap by providing solutions to improve UGI policies and practices that emphasizes adequate financing and effective implementation of UGI in South African cities. I will now provide the proposed framework of my study. Chapter 1 will be the introduction. Chapter 2, the biodiversity crisis in South Africa and the role of government in biodiversity conservation and sustainable urban development. 3, ecological urbanism and its intersections with urban green infrastructure and nature-based solutions to address the biodiversity concerns in cities. 4, towards ecological urbanism in South Africa, an analysis of national law and policy framework for the local environmental governance. 5, towards ecological urbanism in the City of Cape Town, assessing local level law and policy instruments. 6, the conclusion and recommendations. I would like to say thank you for your time and consideration.
Thank you, Aisleen. It's nice to see that there's a very different angle to dealing with challenges around sustainability, so especially through law. So I'm happy that you could join. And I think the next speaker will be myself. So I'm gonna get ready to share this presentation. Screen 2. Here. 5. Can somebody confirm that my screen is visible?
Yes, Prof.
Oh, great. Oh, so I will be taking you through the Green New World Technology Demonstration Platform. And I would like to start by showing you this quite remarkable picture. It's what happened to solar PV cost over the last I think it's 30 years or so. I mean, yeah, no, it's 50, almost 50 years. But 50 years time, the cost of PV panels expressed per watt went down 1,000 times. So a panel in 1976 was 1,000 times more expensive than it is now. And this is really critical to understand, or the opportunities that are basically revealing themselves very much to do. They are very much based on the fact that cost has gone down so much. And a similar trend we can observe with batteries. The batteries haven't been around as long as PV, but it's going down on a similar trend. Even this picture of 2018 was the last one. I think we're now about halfway of that figure. So, and it still seems to continue, even though people at some point said, no, it can't go any lower. You know, new improved technologies, longer duration of the batteries, different chemistries, they're all basically pushing down that cost curve. Now, at the same time, if you look at the cost of electricity based on what Eskom is giving us, that cost has gone up quite significantly. So it's not hard to imagine that at some point these two or these three kind of combined information data points, they will converge into a point where PV plus storage is actually cheaper than grid energy. And we actually already reached that point. So the PV, photovoltaics plus storage, has become cheaper than grid energy. And this is a very strong statement. It's a very powerful event that really opens enormous amount of opportunities. Because if you listen to Professor Patrick's presentation, well, a lot of energy is required to purify water in the future. The water is becoming more and more polluted. We need to spend more energy to take those pollutants out. And this is obviously good news that the energy cost is going down. So we are still within our it's within our means to actually do something about it. So I'm obviously very, very excited about this this development, this movement. Energy is becoming more affordable, but it needs to be guided properly. And I think the farm of the future, what we call it, or the Green New World, offers a unique opportunity to actually deal with, to leverage what we see in the energy space and to apply it into agriculture, and really having the opportunity to reach the lives of an enormous amount of people. So now I'm going to go and explain what Agri-PV exactly is. So it's basically a structure that allows the space underneath panels. So you're raising the PV panels. You can show it. I just want to try to see if I can get my laser pointer here. You raise the PV panels right on top to a height where you are creating a very large space for agriculture. And we can create about 5 jobs for a structure like this. So it's 12 meter long, 20 meter wide, 240 square meter. 5 permanent jobs can be created in the farm industry, whereas you most likely don't even a full job. Not even a full job is needed for the cleaning of the panels and maintenance and those type of things. So it's far more. There's a very high impact on job creation. So what does the Agri-PV do? It assists with food security. You tend to get high quality crops that are growing in shade. They're not exposed to harmful radiation as much as the crops outside. Now, this is obviously not for every crop, but about half of the crops that we're growing, they actually do well if they're partially growing in shade. Another effect of this structure is that it mitigates the impact of climate change, because as weather patterns are changing, and they will change, and they will even become more extreme, you need to protect, you need to start growing your vegetables and fruit even in a protected environment. So this system offers a protected environment. It creates jobs, as I said already. It also helps with water conservation. So these systems, the agricultural space underneath panels, they tend to need less water because there's less evaporation going on. And so you can even get up to 50% reduction of the irrigation needs just by growing in the shade. And then obviously, don't forget about the energy produced. Each system produces more than enough energy for any farm. So if you would, not one system possibly, you need maybe a few of those modules, but then you could power your own tractors, so e-tractors. You could purify your own water. You can pump your own water with your own energy. You could irrigate. You could think about storage of food, building cold chain, cold climates, cold storage that keeps food for much longer. There's an enormous amount of food that gets wasted every year because people don't have means to cool, and they don't have the energy to cool something to keep it fresh for as long as it takes before people consume it. Also energy for food processing. So if you have large amounts of food that are suddenly becoming available because the season it's peak season, and you could process that food to distribute it over more months and guarantee an income for longer periods. Finally, there's an opportunity to create green hydrogen and also green ammonia. Now, why green ammonia is interesting? Because ammonia is one of the very important ingredients for fertilizers. So the farm essentially makes its own fertilizer. So it's a very circular approach. It's I would say the pinnacle of what the water energy food nexus is all about, and it addresses a lot more than the three sustainable development goals that we're discussing today. This is an image of how this project is unfolding. So we are actually, in fact, today is a very important day because we got our approval, the safety file approval yesterday. So the contractors can actually come on site and work, and they will not be stopped by university safety officer because their files are finally in order. And that was after six months of waiting for municipal approvals. So again, it ties into the previous speaker, how law impacts those systems. We need to understand the law properly to move quickly through those processes and make sure that these things can be implemented at a faster pace. So the energy from the agri-PV system gets initially modulated in a container that looks like this picture. So we have a container with lots of inverters and batteries. So the inverters they transform or they convert the DC power to AC power, so we can use it in most of our daily life appliances. We can power a borehole. So this is also a borehole on campus. The borehole is powered by the electricity provided from the AC, from the agri-PV system, and supplies water to the agri-PV system. A portion of the energy will go back into the building or the university grid, in this case, and then a portion of the energy can be used for cold storage. This is a picture from an inside of a cold storage room that is developed in Italy, one of our consortium partners, and that system comes to South Africa. It will be installed in Philippi. That's another site that we're developing at the moment, the Philippi farm. We also can use that energy to charge batteries, either for bikes or the most recent addition is a golf cart that has been converted. There was an old golf cart with lead acid batteries. We took them out. We put our own battery pack in. We designed a battery pack, and we are this system is ready to go. Again, we are busy with some of the safety regulations because now we're moving around in the public roads, or at least on the university site. So the the rules and regulations must apply, and we must comply with certain rules. So that also takes some time, but the whole system is getting together nicely. And I think what is really nice about the system is that there's a whole lot of different departments involved. There's a whole lot of students involved. There's computer science involved. There's economics involved. Because in the end of the day, as scientists, we can all think of nice things and build stuff, but in the end, what really matters is that those systems become affordable and they become sustainable, so economically sustainable as well as ecological and environmental sustainable. So the inclusion of economics is very important. We also have earth sciences involved, and they're looking at the sustainability of the borehole and how we should extract water, and whether there is enough water to sustain a farm of this size. And then there are students from food science. Professor Julian May is involved to look at that aspect of the farm. So and then we have chemistry involved, just to what is chemists actually doing here? So that's one good question. But we need to purify water. We need to do we of course do research in batteries, so we're understanding exactly what is needed there. We're also building a thermal battery at the moment. So there's lots of work to do for a whole lot of different variety of departments. This is the space. You may recognize this space. We started with a fence because we don't want the panels to be stolen the moment they are set up. And this is an aerial view of our building and the space that we're trying to occupy with those agri-PV systems. And then there is plans for expansion. We are quite advanced in hydrogen technology. We are the leaders in the country. We can produce hydrogen with the energy that comes from the agri-PV space. We can produce that hydrogen. We can compress that hydrogen. There's an ongoing project led by Professor Pasupati, who is developing a commercialization of a refilling station for hydrogen. So we've gone quite a long road with that, and that hydrogen can then be used either for forklift refilling or even the drones. I see a lot of potential for drones, where the hydrogen is more effective as a fuel than a battery in a drone, because it has to do with aviation, and the weight of the hydrogen is becoming very important. If you look at drones, the weight of hydrogen is far less than the weight of a battery, or that can do a similar job. And then, of course, the green ammonia. Professor Leslie Patrick is also involved in that project to produce green ammonia from the hydrogen that we're producing. And then there's discussions with biotechnology department that want to get involved with biodigesters, developing the bacteria to effectively convert waste material into energy or to methane. So yeah, it's very exciting to be part of this very big consortium on campus. So the plan of how to expand, I think this is an important thing that addresses the reality of the situation, meaning these systems only make sense if somebody is willing to pay for it, and people are typically willing to pay for something if they become sustainable. If the systems are sustainable, then it makes sense to invest. So we're looking at electricity consumers willing to sign a power purchase agreement. Now those power purchase agreements, they exist. And most of these developments are based on power purchase agreements. So somebody's willing to pay, and then somebody will come and build it. That's basically what it means. So you have the EPCs, the procurement and construction, engineering, procurement and construction companies. If they see there is a client, they can find the funds to actually build something, because they know when they're done building, they can sell that electricity. They can sell the electricity to the client, and that will pay back for the investment. So these are currently ongoing. This is a Kenhardt very large site in Kenhardt in the Northern Cape. You can see all these panels are mounted on the ground, but underneath the panels, nothing is going on. It's basically dead soil for the next 20 years. Even in this case, you're not going to utilize the soil anymore. You just utilize the PV panels and the energy. So what we would like to do is to say, no, if you are about to close those deals where people are interested in your electricity, we would like to get involved. This is just to repeat that these structures really make sense. In many cases, they started to make sense a few years ago, and now they're really making a lot of sense in terms of they're economically viable systems. But as I said, the ground is not considered to be used. So what we with this alone, we are missing out something. We're not utilizing the space. We're not utilizing our capital, the human resource capital. So what UWC and investors are trying to do, the moment you have a situation where an electrical consumer is willing to sign a PPA and we have an EPC that wants to build a structure, we say, hold on, we will raise funds to raise the panels. So now you're sitting with a structure like this. One of them, Philippi Farmers structure, has gone up. And with that, you then create an opportunity to improve the electricity production, because as you keep the temperature lower underneath the panels with all the growth of the vegetables, the solar panels become more efficient. So there's actually an improvement in electricity production. There's massive social economic impact through food security, improved access to food, jobs, obviously. So those are the benefits that normally they're not as critical for the people that want either to buy electricity or to build these plants. But the socio-economic benefits are really huge. And I think that is the reason why an investor is going to, we won't have much difficulty to find investors, because they see the value of the socio-economic impact. They see the value of people getting jobs, people paying taxes, people, and getting more resilience towards climate change. So it also promotes sustainable, low water intensity farming, which are all very, very important if we want to see our food production to continue in the future. Lastly, to reach economic feasibility and roll out on a large scale, we are solving, in that process, we solve energy, water, and food supply chain challenges. So to me, this is the answer to food shortage, to energy shortage, to water shortage. And with that, I would like to thank you and our funders, specifically the DSTI has been very instrumental in the funding that we received. And recently also the EU that has put some significant money into development, and the various companies that have been supplying us and donating us with a certain piece of equipment. So thank you very much. I'll stop sharing now. And I guess we are ready now to go to the Q&A session. I see there's two questions, but there may be more. So let's start with the first question, if you don't mind, and then we see if others will follow. So the first question was raised by Garine Phillips, and it's for Leslie. It says, if the city is not listening to an expert like yourself about water, what kind of advice are they relying upon to make decisions about our waters? For example, your comment about potential desalination plant not being well located. I think it's an excellent question, and I hope that Leslie can, or Patrick can give an answer that is not too negative.
Yeah, thanks for the question. The city has somewhat modified its attitude towards our research, and they are, shall we say, taking a small bit of it into account. I do find that engineers, unfortunately, especially the water and sanitation engineers, are very stuck in their old world paradigm of doing microbial bioremediation, if one can call it that way, for wastewater treatment plants. And the trouble is that that technology, which was developed more than 40 years ago, did not have to deal with all the chemical contaminants that we're throwing down our drains these days. And the trouble with our chemical usage is that we knock out the beneficial bacteria that are supposed to be doing the job in the wastewater treatment plants. And therefore the plants keep on not functioning properly. So your sewage is just actually visiting the wastewater treatment plant and shedding a little bit of its rubbish and then carrying on. The city is modifying several of the wastewater treatment plants to try and enlarge them and improve their capacity, but they're still stuck on that old technology. And we have been trying to tell them about how to improve the treatment train by having better monitoring and better guidelines, and of course better technologies. And I do hope they are listening, because the fact is that that wastewater reuse plant in Foray is been given the go-ahead. I don't know if any of you've noticed, there have been calls for public participation, and I please ask you to go and do the public participation. Write to the city and raise your concerns, because unless more people than me, by myself, raise concerns, the city is not going to listen. I think that there are many ways in which our water security can be improved. Ben has shown us one way. Leak detection and fixing up our infrastructure would be a different way to go about it. If you look at all the spillages and contamination that goes into our rivers, it's actually horrific. And almost none of our Cape Town rivers are actually clean water anymore. They're basically sewage effluent. Go and look at them. You just have to drive over the Black River to see what I'm talking about. It's basically solid sewage. Our rivers have got no dilution capacity. So talking about who the city is listening to, for the wastewater treatment plant that's going to be turned into a reuse plant at Foray, they have appointed an international panel of experts. And my contention is these people haven't got skin in the game. We've got skin in the game. We should be asked to serve on those panels, but the city is neatly avoiding to ask local expertise onto those panels. And every time you talk to them, they put their noses up in the air and they say, we're talking to international experts, like you, the local little silly person here. What can you tell us? So sorry, I have to be negative, but please raise your concerns, because it's your future. Thanks.
Yeah, no, thank you very much, Leslie. I think we need to also be mindful that doing this research and going against the old standards is not very popular, because you are basically you're telling the people that trying to do their jobs according to and comply according to old standards that they're no longer doing the job right, and that obviously causes friction and anger and whatever. I can imagine. It's really not nice to tell anybody that they do something wrong, especially not the city of Cape Town, because they obviously they don't feel proud of what they're doing if they find out what they're doing. So, but it is absolutely necessary, and I think we need
if I can just
for that.
You know, our speaker that spoke about the legal framework and the biodiversity issue, this is really a crying need to get the legal framework sorted out. Your work is terribly important. And we really need to consider what is happening to our environment because of our poor quality water. I showed you how our marine environment is being affected. Our rivers are dead. Our estuaries are dead. And our marine environment is slowly dying. And unless we actually become much stricter about what we use ourselves and what we throw into the environment and how we take it out, we're not going to win this battle. So it's also a case of informing the public about their choices. You know, when you take Panado, your body only uses a small portion of that Panado, and most of it goes out in the toilet, and the rest of it goes to the sea, and it gets into our marine life. So please don't take 5 headache pills if 1 headache pill will do. You know, that's just an example. We really need to be thinking.
Great. No, thank you. I will take one other type of question, and then we most likely can still move back because there's still more questions around how we should deal with pollutants in the future. But let's move to a quick question from Kanyisile Ngubo that is directed to Rida Manuel, and he is asking, assuming that's he. How do we see the system developing in the next few years? And are there opportunities for students to get involved in research or projects related to that? So Rida, you have an answer?
Okay, thanks for that. So the plan, as we mentioned, is that Islamic Relief will be funding the rollout of 50 of these solar-powered hydroponic systems across Western Cape and KwaZulu-Natal, mostly in the low-cost housing. In our area, for example, it's going to be Khayelitsha and Mitchells Plain. But obviously, these systems is manufactured by our students here in our graduate program. And so that is the opportunity basically for students, engineering students mostly, but anybody with that has passion for this industry and has the skills we're willing to take on. And so that is the opportunity is basically to come through our graduate program, and you'll be directly involved in the manufacturing of these systems. Thanks.
Yeah. So quite a lot of opportunities. The idea also with the Green New World is that it becomes a living laboratory. So it is supposed to be swamped by students that want to test different aspects of different systems, whether it's a biodigester or whether it's an insect farm or whether it's a fish farm, or so all these different aspects, water purification system, or the energy, how energy is stored, you know, either with batteries or with thermal batteries, ice batteries. So it actually allows to be very accommodating a very large portion of the students at UWC, and even law students and computer science, what was it, statistics, for instance. So you wouldn't normally think of how all these different people can actually fit in the system, but because the system is very complex, and as you work with very complicated systems, very integrated systems, and exactly that what we want to do. We don't want to work in silos on an isolated problem. We need to take the problem as a whole, and that actually that allows a large variety of disciplines to participate. So I don't see any questions in any more questions, but I would like to ask. Rida has one himself.
So yes, my question is to Prof. Leslie. So obviously that presentation was quite shocking. So for many years now, we've basically been focusing on the problems caused by our energy production and food production. I don't think I was knew the extent of the problems caused by our water production, if you can call it that. And so I'm obviously gonna do some more studying based on your presentation you sent, and we'll try to also promote it on my social media platforms. I've never been speaking about water much. Actually, I have a few questions, but I don't think there's time for all of it. The first one is, should we be drinking our tap water that's coming out of our taps at homes? And if based on your research not, what is the best alternative for good quality water to source it basically?
Well, look, at the moment, I don't think there's cause for alarm. The city hasn't started injecting this water into our system. For a period of time, they were injecting the water from the desalination plants into our reticulation system. And unfortunately, at Monwabizi, the water that they were injecting was not of good quality, and the community complained so much that they had to stop supplying those part of the communities. You know, the desalination story is quite a tricky story because the monitoring that the city was doing was just the electroconductivity. And the thing is, the electroconductivity goes up quite a bit before they actually start cleaning their membranes. And by the time the electroconductivity goes up to the point where they were willing to go and clean their membranes, people are already tasting the salt in the water, because our taste buds are very sensitive. And that is one of the problems, is that was the only way they were monitoring the water. And that has stopped. They have closed those desalination plants down. The Pardon Island desalination plant, which they're currently planning to do, is only going to be online something like in 2029. And they seem to be very determined to carry on with that. The waterfront, the V&A waterfront, is already running a desalination plant. So I'd be a bit nervous about using the desalination, the potable water at the waterfront. Certainly, they're already flushing all their toilets with reused sewage. If you go and look at their toilets, you'll see their toilets are never really clean. The water there is not clean water. So, you know, one of the things that nobody has explored is dry toilets. And I really think that we need to move away from flushing our toilets with potable water to using dry toilets, because there are many designs of dry toilets that are actually perfectly hygienic and don't stink. There have been many attempts to improve the design of flushing toilets, even to use minimal water. And you can see examples of that down at the Blue Root Center, where they use a vacuum system and a tiny bit of water to flush the toilet. So I think we have to pay attention to these innovations. And certainly, I think people need to become very aware of their chemical usage. So if you can promote that on your Facebook platform, and please visit our Water Stories website. We've got a website called waterstories.co.za, where we have a lot of this information, also of the options to improve matters and what you can do personally to use greener household products, and not spray your house with all kinds of insecticides and so on. So please go and look at that website. There's lots of stuff there.
Yeah, great. So I think a large portion of the problem is actually is sitting with the people. It's not so much throwing technology or more energy or more, because everything can be cleaned, but it's possibly easier and less costly if people start becoming more aware and using less detergents, less this, less that. I mean, I'm not sure if I recall correctly, Leslie. A few years ago, you mentioned that some toothpaste brands were using microgranules as plastic granules to make your teeth, of course, more clean or more effectively. And only many years later, the whole idea about microplastics is becoming more in the news, and the awareness is made. But meanwhile, I'm sure that those factories are still producing those toothpaste because they sell well, and that's all that counts, right? And as long as there's no law that says anything, that's again highlighting the importance of the law and to regulate these things, because if somebody's complaining about microplastics in the environment, but you're still brushing your teeth with microgranules and you're not even aware of it. Most people just buy toothpaste and just don't know. So I'm not sure if those microplastics are the actual ones that they're talking about, or there's a variety of microplastics. But is one of those, could it come from toothpaste?
Yes. You know, the thing is, there are many different personal care products that contain these microplastics. You can just think about the body scrubs and the facial scrubs. You can also just pay attention to the fact that many people are using wet wipes and throwing them down the toilet which is also breaks down into microplastics. Also washing our clothes, if we've got polyester and these non-woven jackets on and we wash them, those things are releasing microplastics, huge amount of microplastics. So it's also your choice of your clothes. What are you buying and how often are you washing it? Because all of that goes into the sea. So, you know, the microplastics are at least somewhat visible, and the wet wipes block the sewage system. So actually the city has to go and unblock them and then take all those wet wipes and go and dump them on the city dump. But nobody sees the chemicals. And, you know, a lot of people, on the landfills, and nobody sees the chemicals. The chemicals just slip right through. It's the invisible threat that nobody's paying any attention to. And, you know, when you think about these chemicals, we're finding unmetabolized pharmaceuticals in the environment, whereas your body should be metabolizing those compounds properly. And we haven't even started looking for the metabolites in the sea. So what we're seeing, as I said in my talk, is just the tip of the iceberg. And, you know, when we've done multi-scan QC-TOF type of analyses on these samples that we took out, we've found more than 1,000 other compounds in those mussels and sea urchins and so on. And the trouble is that we're the same as those creatures. We bioaccumulate those compounds, and they build up in our bodies. And, you know, the very sad thing about this is actually a lot of these compounds partition to the fatty tissue, and that means that partition to the breast milk. So many women get rid of their contaminants by feeding their babies breast milk, and these contaminants pass through into the breast milk and into the baby. And this happens to mammals out in the ocean as well. And they've actually documented dolphins whose babies die because of the huge amount of contaminants that the mother actually passes on to their babies. So this is a huge environmental disaster, and it's absolutely invisible. Nobody's paying attention to it, and very few people are raising the awareness. So you'll have to excuse me. I try and make as much noise about this as possible because I seem to be the only person in the whole of South Africa who's willing to talk about it.
Yeah, it's a sad story. Yeah, no, it's but I think the most effective way would be that people start using it less. But it's very difficult. Even in my own household, it will be quite. I will be looked down upon. Say, why, what? You know, that type of, because it's one day, and it could, even after a day like this, everybody's excited or made aware of it and all pondering, and then it just next week is kind of back to normal, because there's no law, there's no nothing. There's just, so it's a very hard barrier to break, I think. And
yes, you know, we've become used to using chemicals to solve all our problems. And this is just a new thing. I mean, in the olden days when I was young, we used vinegar and bicarbonate and things like that to clean the house. We didn't use all these modern chemicals, and people think that a chemical can solve every problem. And, you know, us chemists also need to take a bit of ownership here, because we keep on making new molecules that nature has never seen before.
Yeah. I don't know if there's still a bit of time for questions. So Rita, you said you had another question. I do have one more question, but let me see if there's anybody else having any questions. So yeah, I think it was when I was looking at your slides, Leslie, a lot of interesting information. You were going very quick because of course you can't. You only have 15 minutes to make to give us a story that should take 2 hours. But so a lot of these slides, I think I saw that the contaminants in Europe were much lower than the contaminants in Cape Town specifically.
Yes.
And the question is that on the supply side? I mean, are the the German citizens more aware of what they throw down the drain than South Africans, or is it on the purification side where the systems not even Germany, because Germany was actually not available, the data, but other European countries, are their systems more up to date? Do they have more stringent laws, or what is your opinion about that?
Well, I think it's all of that. One of the certain things is that many compounds that we use in South Africa are actually banned in Europe and in America. So a lot of those companies like compounds in South Africa because they can't sell them in Europe. So that is one of the reasons why we're finding banned compounds here. The other thing is, of course, that in Europe, almost all the wastewater treatment plants are functioning, whereas in South Africa, we've actually got more than 83% of our wastewater treatment plants. Please take note, guys, more than 83% of our wastewater treatment plants are almost completely non-functional. You have no idea what problem we face and how difficult it's going to be to fix this problem. Because even just bringing the wastewater treatment plants up to normal functioning is not going to take these chemicals out. And we haven't got the money to fix this up. It's been neglected for too long. So there's that issue. Then the other issue is, of course, in South Africa, we have a large AIDS population that receive medication on a daily basis. And also people go to clinics and they get given medicines for 6 months at a time so that they don't have to come back to the clinic. And a lot of those medicines are not taken. And we don't have a decent take-back policy at the pharmacists to take back the unused medication. Whereas in Europe, they do have those kind of regulations in place. And I think that Europe has got very much better guidelines and laws in terms of the quality of water that you may release. And the monitoring of the wastewater treatment plants is much stricter. You know, here in Cape Town, for instance, we've been trying to fix Potsdam up for the last 7, 8, 9 years. And even though the city has been putting a lot of money into fixing Potsdam wastewater treatment plant, directive after directive from the Department of Environmental Affairs is just ignored by the city. They just say, sorry, we can't do it. Sorry, we can't fix it. Sorry this, sorry that. And because of cooperative governance, there is no punitive measures implemented against the cities that are not doing their job properly. Whereas in Europe, you will be slammed so quickly. You will not get away with not doing your job. But having said that, England is in a very big pickle. I don't know if you've watched the news, because in England, they actually outsourced all the wastewater treatment plants to private companies. And those guys have been profit sharing and profit taking, and they've not been looking after the wastewater treatment plants. And England is in a dire straits as well. It's not South Africa is not the only place.
Yeah, I don't know if that's the good note or bad note to end on, that the UK is also bad. But I think it's very important that we are confronted with the reality occasionally, and maybe more. It should become more in your face so that people actually become aware when they throw something away, or when they wash, or when they use detergents or cleaning agents and things. That will make a big change, I think, already. I think we, I don't know if there are no more questions. Then I'm just wrapping up. I don't know. Okay, there's Rida is still one question.
This is one question. So like I said, I'm very alarmed, and definitely going to do more research based on this website you gave me. And I might contact you a bit later also for some more sources of insight into this, to help you make that noise. But
thank you.
So because I've made a lot of changes in my diet recently. I was very careful about where I was sourcing my food from, and I found that I was getting much less sick and I have much more energy. So there's definitely going to be, I'm going to find this link between the water. I thought it was just the way we're producing our food, but I see it's linked to our water as well. And I'm sure I'm going to find that link based on everything you said now. There was one thing you said about how the water affects the kind of sexual nature of the of the population, basically. And there was a lot of theories going around recently about how the water is basically causing, I don't know word this properly, youngsters to be confused about their sexual nature. And you presented some facts to basically show that this is a scientific fact. It's not a theory. You spoke about estrogen and those chemicals, and I just wanted to know if you can elaborate more on that, because that is a very big topic in some circles right now.
Yes, look, it is a real big fact. It's inadvertent. I don't think anybody's deliberately trying to cause sexual changes in people, but we get these estrogen mimicking compounds from so many different directions. I mean, I've got a little till slip here. These things, I don't know if you can see it, are coated with a compound that burns black. It's when it gets printed, and that when you handle these till slips, you're picking up these compounds that will cause your sexuality to be altered. We have them from our perfluorinated compounds, and from many other surfaces are actually made waterproof. And even your computer has got chemicals on it to make it waterproof. And I'm sure you don't think of washing your hands after you've touched your computer. So we're getting these compounds in all kinds of ways. Pesticides particularly are very problematic. And if you go and look at Akhil Dalvi's study, he's been looking at a spray drift from spraying pesticides over agricultural lands. And kids that are exposed to spray drift are definitely having developmental abnormalities and actually learning difficulties. So it's not just from the water, it is coming to you through the air and through the food that you eat and through things that you touch and put in your mouth, etc. So we really need to pay attention to all these chemicals. You know, the fact of the matter is our granddads had a far higher sperm count than our current youngsters. I think the figures are something like we have about 10% of the sperm count that our granddads had because of the exposure to all of these chemicals. And you'll notice that a lot of this is happening in the developed world, where people are infertile and having troubles to have babies, and that a lot of these chemicals also cause hermaphroditism, like in fish. A fish will actually change its sex completely if it's exposed to some of these chemicals. It'll turn from a male into a female or a hermaphrodite. So we should not take these things lightly. It's simply not safe. We've recently published a paper with our spermatology colleagues from biosciences, where we talk about the impact of these compounds on human sperm. So please go and read it. It is out there. Prof. Liana Maria and I have published it. So yeah, I do think we need to pay attention to this, because the way we're living, we can't carry on like this. It also relates to the amount of cancers that people are getting.
Yeah,
it's really an invisible scourge. One other thing I just want to say on this point is our city sprays all our pavements with poison, with pesticides, to get rid of weeds. And we've got a group called Unpoison. You can go and look for them, Unpoison, where we're actually trying to get the city to stop spraying the pavements. There's also a group called Poison Free Peninsula that's trying to get the city to stop spraying the pavements with poisons. So please, if you see a weed on your pavement, go and dig it up and pull it out so that they don't have to spray poison on your doorstep. Because this is also causing spray drift.
Yeah. Yeah, it looks like the solutions are far more on the information and willingness of people side than technology.
Yeah.
Okay. Yeah. I don't know, Tamara, is there anything from your side before I
No.
can close?
No, Prof, nothing from my side. But I would
Yes.
like to thank the presenters and yourself as well for just taking out the time to share with us this insightful information. We take for granted the very things that each presenter was speaking about. And I'm not in this field, but my eyes and ears have been opened and I'm alerted and more aware of what I need to look out for and how I can change things as well. And not be a contributor to it, but rather a solution bearer to it. So I just want to say thank you so much, Prof. Bladegroen, also for moderating the session today with us. And I hope this won't be the last and that there will be many more. Thank you so much, Prof. And to the presenters as well. Thank you.
Yeah, thank you. Thank you too, and all the participants. It was very interesting.
Thank you.
Okay, I'm gonna close. Leave.